In this video, we're solving a second-order differential equation using coupled equations. In this example, we're solving the equation y prime prime minus 16y equals 16t squared, with the initial conditions y prime of 0 equals 1 and y of 0 equals 0. So the first step is that we need to solve the corresponding homogeneous equation. So to make this into a homogeneous equation, we replace the right-hand side with 0. So this gives us y prime prime minus 0y prime minus 16y equals 0. It's now replacing y prime with x. This means we also replace y prime prime with x prime. We get the equation x prime minus 0x minus 16y equals 0. And we can rearrange this to get the coupled system. X prime is equal to 0x plus 16y. And rearranging x equals y prime, we get that y prime is equal to x plus 0y. So notice that we've aligned the x's and the y's in a column. This allows us to do the next step, which is to convert into matrix form. So the left-hand side becomes x prime, y prime. And then taking the coefficients out as a matrix, we get 0, 16, 1, 0, multiplied by our variables matrix xy. This allows us to define the matrices A. A is our coefficients, 0, 16, 1, 0, and x is our variables matrix xy. So we can rewrite this system as x prime equals ax. So once we've wrote this system in matrix form, we then want to find the eigenvalues of A. So to do this, we solve the equation determinant of A minus lambda I equals 0. A is our coefficients matrix. Lambda are the eigenvalues to be found, and I is the identity matrix 1, 0, 0, 1. So performing the scalar multiplication of the lambda with the identity matrix and then subtracting, we get the determinant of minus lambda 16, 1 minus lambda is equal to 0. So to take the determinant, we do the difference of the product of the diagonals. We do minus lambda times minus lambda minus the 16 times the 1 is equal to 0. So expanding the brackets, we get the quadratic lambda squared minus 16 equals 0. And we want to solve this to find lambda. So in this case, we can notice that this is the difference of two squares. So we can rewrite this as lambda plus 4 times lambda minus 4 is equal to 0, which gives us that lambda is equal to 4 or minus 4. Now we want to find the eigenvectors of A corresponding to each of the eigenvalues. So starting with the eigenvalue of lambda equals to 4, we're looking for the solutions to the equation A minus lambda I times x is equal to 0. A is our coefficients matrix, lambda is 4, and I is the identity matrix 1, 0, 0, 1. Performing the scalar multiplication and subtracting this from A, we get that A minus lambda I is equal to minus 4, 16, 1, minus 4. This is multiplied by xy, and it's equal to 0. Expanding the brackets, performing matrix multiplication, we get the entries minus 4x plus 16y is equal to 0, and x minus 4y is equal to 0. So we get a pair of simultaneous equations that we need to solve for xy. We have infinitely many solutions, so we just want to find a vector in the direction of this line of solutions. So to do this, we can take any non-zero value for y and then find the corresponding x value. So to keep it simple, I'm going to choose y is equal to 1. And then if y is equal to 1, by the second equation, x is equal to 4y, so x is equal to 4. So our first eigenvector is the vector v1 equals 4, 1. And now we do the same to find the eigenvector of A corresponding to the eigenvalue of -4. So starting with that same equation, A minus lambda I times x equals 0, but this time taking lambda is equal to -4. So simplifying A minus lambda I, we get 4, 16, 1, 4. And then performing the matrix multiplication, we get 4x plus 16y and x plus 4y, and these are equal to 0. So we've got a pair of simultaneous equations, 4x plus 16y equals 0, and x plus 4y equals 0. So again, we have free choice over one of the variables, as long as it's non-zero. We're going to take y is equal to 1 this time. And by the second equation, x is equal to -4y, which means that if y is equal to 1, x is equal to -4, giving us the second eigenvector v2 equals -4, 1. So we can now solve the corresponding homogeneous system. So because we have two distinct real eigenvalues, we can use the form of the equation x equals c1 v1 e to the lambda 1t plus c2 v2 e to the lambda 2t, where v1 is the eigenvector corresponding to eigenvalue lambda 1, and v2 is the eigenvector corresponding to eigenvalue lambda 2, and c1, c2 constants to be determined. So substituting, lambda 1 equals 4, so v1 is the eigenvector for 1, and substituting lambda 2 equals -4, giving us v2 is the eigenvector -4, 1. So reading off the equations, so the first row gives us x equals 4c1 e to the 4t minus 4c2 e to the -4t, and the second row gives us y equals c1 e to the 4t plus c2 e to the -4t. So now we've solved the corresponding homogeneous system, we need to look at the specific solution for the non-homogeneous part. Start with the x prime equals ax, but now we need to add on the 16t squared. And in the second row, we add a 0 because this represents the equation x equals y prime. So what we want to do is guess a specific solution to the non-homogeneous equation. So assuming that our specific solution is of the same form as the forcing function, it has to be quadratic. So to do this, we're going to replace the x's and the y's with a quadratic, which is unknown. So we let the x be d1t squared plus d2t plus d3. And we let the y also be quadratic, so it becomes e1t squared plus e2t plus e3. And then we take the x prime and the y prime to be the derivatives of these. So x prime becomes 2d1t plus d2, and y prime becomes 2e1t plus e2. And we can expand and simplify. Get that 2d1t plus d2 and 2e1t plus e2 is equal to 16t squared plus 16e1t squared plus 16e2t plus 16e3 and d1t squared plus d2t plus d3. So we can now compare coefficients. So in the first equation, we want to compare the coefficients of the t squareds. So on the left-hand side, we have 0, and on the right-hand side, we have 16 plus 16e1, which means that 0 is equal to 16 plus 16e1. Comparing the coefficients of t, on the left-hand side, we have 2d1, on the right-hand side, we have 16e2. Then comparing the numbers, so on the left-hand side, we have d2, and this has to be equal to the right-hand side, which is 16e3. Doing the same with the second equation, so comparing the coefficients of the t squareds, we get that 0 is equal to d1. Comparing the coefficients for the t, we have 2e1 is equal to d2, and comparing the numbers, we get e2 is equal to d3. So we have a set of 6 simultaneous equations in 6 unknowns. So we can read off that d1 is equal to 0. So we know that 16e2 is equal to 2d1, which gives us that e2 is also equal to 0. So d3 is equal to e2, which means that d3 is also equal to 0. We know that from the first equation, 0 equals 16 plus 16e1. We get that e1 is equal to minus 1. d2 equals 2e1, so d2 is equal to minus 2. And then finally, we can find e3. So using the last equation, d2 equals 16e3. Using d2 equals minus 2, we can solve to get that e3 is equal to minus 1 over 8. And this allows us to write the general solution by putting these values in for our quadratic. So we get that xy equals c1 41 e to the 4t plus c2 minus 41 e to the minus 4t plus minus 2t minus t squared minus 1 over 8. So this gives us a pair of equations. So x equals 4c1 e to the 4t minus 4c2 e to the minus 4t minus 2t, and y equals c1 e to the 4t plus c2 e to the minus 4t minus t squared minus 1 over 8. So we can substitute in the initial conditions. Y prime of 0 equals 1 and y of 0 equals 0. So the number in brackets means that both of these conditions are when t is equal to 0. So the y of 0 equals 0 means that y is equal to 0, and y prime of 0 is equal to x, which means that x is equal to 1. So substituting these in, we get the pair of simultaneous equations. 1 equals 4c1 minus 4c2, and 0 equals c1 plus c2 minus 1 over 8. Again, we can solve these with any method that you know. So you could use substitution, elimination, a calculator, or MATLAB. So solving these, we get the solution c1 equals 3 over 16, and c2 equals minus 1 over 16. And this allows us to write the particular solution. So substituting these values in, we get that xy equals 3 over 16, 4, 1, e to the 4t, minus 1 over 16, minus 4, 1, e to the minus 4t, plus minus 2t, minus t squared minus 1 over 8. So remember that top row is our derivative, the x, which is y prime, and that second row is our solution for y. So we can read off the solution by reading that second row. Y equals 3 over 16 e to the 4t minus 1 over 16 e to the minus 4t minus t squared minus 1 over 8.